Okay, hello everyone. So in our last lecture, or we can say in our last video, we are discussing about the energy principles related to stress and strain. That means in energy principle that we have to study about the various relationships between stress or strain or deformation or displacement or material properties of steel and concrete. Okay, so let us go through the next part of the lecture, which will be basically we will go through the outlines of the portions which we will be studying in details in our next chapters or next lectures. Okay, so here we have to go through general principles, virtual work principle, principle of virtual displacements, principle of virtual forces, unit dummy force method, elastic systems, minimum total potential energy principle, or next is principle of stationary total complementary potential energy. Okay, so actually these are nothing but the various methods by which we can study the different properties of materials or stress strain relationships, or by these methods, by virtual work or dummy load method, we can find out the displacement or deflection of concrete or RCC beams and columns. Okay, so these are basically just the names or principles by which we can go through the material properties or stress strain relationships or deformation or deflections of RCC structures. Okay, so next is Castigliano's first theorem. So Castigliano's with this we will study Castigliano's first theorem in details in the later part of the course. But for your basic knowledge, I will tell you that this Castigliano's first theorem will be used for finding out the deflection of RCC beams or portal frames. Okay, so it has various other uses also, but we will be basically dealing with the deflection part. Then linear elastic systems, then Castigliano's second theorem, as you can see for Castigliano's second theorem is also used for finding out displacements. So displacement means it is nothing but the deflection. Deflection means if you, as you know that the RCC beams are subjected to loads. Loads means it might be your live load, dead load, or wind load or earthquake load. Okay, so under these loads, these structures undergo some vertical deflection. Okay, so deflection means when you construct the structure, so after putting the load, how much it will be deflected from the original position. It will be that the vertical distance will be known as deflection. So deflection will be your deflection might be your vertical deflection or horizontal deflection based upon the type of load you are applying. So if the load is applied vertically, so deflection will also occurs in the direction of load. That means it will occur in the vertical direction. Similarly, if we apply load in horizontal direction in any structure, so the deflection will also occur in horizontal direction. That means you have to remember that the deflection always occurs along the direction of applied load. Okay, so there are various methods which we will be studying in the later part of the course by which we can find out the deflection of structures. That means it might be your horizontal deflection or vertical deflection. Okay, so while designing a structure, we have to keep in mind that your structure must be resistant to deflection. That means you can't resist deflection completely, but the deflection must be minimum. That means your deflection must be within the permissible limit. Otherwise, if your deflection will be more, that means you didn't design the structure properly. So if your deflection will be more, so finally some cracks will be developed and finally it will collapse or it will fail. So we have to keep in mind while designing any structure or any RCC structure that we have to minimize the amount of deflection. Okay, then Betty's reciprocal theorem. This is also a theorem to find out deflection in RCC structures. Then Muller-Bristol principle is also used for finding out deflection, or it will be used to find out the end moments. Then we will see the applications of this Muller-Bristol principle. Then we will see the various governing equations by variational principles. Then we will see the approximate solution methods. Then we will also go through some basic things about finite element method in structural mechanics, and which is, if you go for higher study in structural engineering, so this finite element method will be very, very useful. So you have to understand, basically in this first chapter we will be only going through the theory portions. In the later part of the course we will be solving some numericals based on these methods, so that it will be very helpful for you to understand the different methods and how we can apply these methods to find out stress, find out your deflections or displacements or fixed end moments, etc. Okay, so in our next part of the lecture we will be going through some other applications or other theorems or okay, which will be needed in this chapter. So this is all about our first chapter, and in our next part of the video I will tell you tell you the things which we have discussed in this lecture. Okay, thank you. So hope to see you all in our next part of the video.